Assalamualaikum and hi everyone. We are from Group 15. Today we will present our topic, analysis of water quality using pH measurement and acid-base titration. First, introduction of water quality. First, let us understand what the water quality means. Water quality refers to physical, chemical and biological characteristics of water that determine whether the water is safe and suitable for various uses such as drinking, industrial purpose and environmental application. Next, I will explain the importance of water quality and parameter tests in this study. Water quality is important because it directly affects human health, environmental balance, and ecosystem stability. Clean water is essential for daily activities such as drinking, agriculture, and domestic use. Poor water quality can negatively affect both of human and the environment. In this study, the main parameters tests are pH level, acid-base titration, and alkalinity. The pH level is used to determine whether the water is acidic, neutral, or alkaline. Acid-base titration helps analyze the concentration of acidic or basic substance in the water sample. Meanwhile, alkalinity indicates the water ability to resist changes in pH.
So hot.
Wait, I want to drink water. Guys, I was thinking whether the water we drink is safe or not.
Yeah, I always wondering, does all of this water is safe to drink? I've been wanting to watch how the water quality test been running.
Isn't that Damia?
Oh, hi!
Guys, what are you guys doing?
Hi! Oh, we've been wondering how our this water in this world is safe or clean to use in our daily life.
Oh, I see.
If you guys wondering, I could show you guys how the water is safe to use in our daily life by running a quality test. Let's go!
Before we went to the procedure of titration, I will explain what is volumetric analysis and what is principle of titration. Volumetric analysis is quantitative analytical method used to determine the concentration of unknown solution by measuring the volume of standard solution required for a complete reaction. In this experiment, we use acid-base titration to determine the alkalinity of the water sample. A standard hydrochloric acid or HCl is added gradually from the burette to the water sample in the conical flask. The principle of titration is based on the neutralization reaction between acid and base, where acid is added to base form a water and salt. As the HCl react with the alkaline substance in the water sample, the reaction is continued until the endpoint is reached. The endpoint is identified by a color change of the indicator. The volume of HCl used is then recorded and used to calculate the alkalinity of the water sample.
I'm gonna introduce you guys to the apparatus that we're gonna use in titration. So, we have pipette, we have funnel, we also have white tile, we have conical flask and burette. First, this is the setup of the titration. We have a retort stand as the support for the burette. Burette allow acid to act slowly and accurately during titration process. We have a conical flask where the reaction takes place. This is where we add the indicator and the water sample for the titration process. Next, we also have a funnel to fill the burette without spilling any solution. We also have a white tile. White tile function for us to observe the color of the solution. As well as this, we also have a pipette to measure and transfer the exact amount of water sample into the conical flask, as you can see here. You guys have to take note, we also need to pipette until the calibration mark to get the exact volume that we want.
Now, let's look at the experimental setup and procedure. First, the burette is filled with standard hydrochloric acid solution. Next, a pipette is used to transfer the water sample solution into the conical flask. A few drops of indicators such as phenolphthalein is added to the water sample. During titration, the acid is added slowly from the burette to the conical flask while the conical flask is gently swirled to ensure the complete mixing of both solutions. When the indicator changes the color, the endpoint has been reached, which means the neutralization reaction is complete. Finally, the initial and final burette reading are recorded, and the volume of HCl is used to calculate and determine the alkalinity of the water sample. To sum up, volumetric analysis is a simple, accurate, and reliable method for analyzing water quality. The acid-base titration technique allows us to determine the alkalinity of the water by measuring the volume of standard acid needed to neutralize the sample. Last but not least, the use of accurate apparatus, proper titration technique, and correct identification of endpoint ensures reliable and precise result in water quality analysis.
Now
Now, let's look at the results obtained from the volumetric analysis. A rough titration was first carried out, giving a titer value of 24.4 cm3. This value was used only as a guide and was not included in the final calculation. 3 accurate titrations were then performed. The titer values obtained were 23.85 cm, 23.8 cm, and 23.8 cm3. These values are very close to one another, showing good precision and consistency in the experiment. The average titer was calculated to be 23.82 cm3. Since the results are concordant, we can conclude that the titration was carried out accurately and that the average titer is reliable for determining the concentration of the analyte in the water sample.
Before we discuss about pH meter, let's first understand what exactly pH is. pH is a scale used to measure how acidic or alkaline a solution is. As we already know, the pH scale ranges from 0 to 14. The pH 7 shows a neutral solution, while the pH above 7 shows an alkaline or basic solution. And lastly, the pH below 7 indicates an acidic solution. That's why understanding pH is important in our daily life because it helps determine the quality and safety of water. Now, as we already know about pH, let's talk about pH meter. What exactly is pH meter? pH meter is an electronic instrument that used to measure the pH of a solution accurately. It consists of 2 main parts, which is a probe and a digital display. The probe is placed into the water sample where it detects the hydrogen ion activity. The meter then converts the information into a pH reading shown on the display. In water testing, a pH meter provides fast and reliable results, making it an essential tool for monitoring water quality.
Firstly, before you begin to calibrate and use your pH meter, you will first need to turn it on and allow adequate time for the meter to warm up. Next, you will generally need more than one buffer for calibrating a pH meter. Once you have chosen your buffers, allow them to reach the same temperature as the pH meter because pH readings are temperature dependent. Once your electrode is placed in the buffer, allow the pH reading to stabilize before letting it sit for approximately 1 to 2 minutes. Once you have a stable reading, set the pH meter to the value of the buffer's pH by pressing the measure button a second time. Next, rinse your electrode with distilled water and pat dry with a lint-free tissue in between buffers. Set the pH meter to the value of the buffer's pH by pressing the measure button. And lastly, rinse your electrode again with the distilled water. For the part 3, the first step is place your electrode in your sample and begin reading. Press the measure button and leave the electrode in your sample for 1 to 2 minutes. Secondly, set your pH level. Press the measure button and this is the pH level of your sample. Lastly, clean your electrode with distilled water. This is an example result for the water testing using a pH meter.
Now, I will explain the applications of this acid-base titration. This acid-base titration is widely used in water analysis to determine the acidity and alkalinity of water. This helps us to assess the water quality and ensure that it is safe for domestic, industrial, and environmental use. Next, pH and alkalinity are closely related but slightly different. pH measures how acidic and basic the water is. Meanwhile, alkalinity measures how the resist changes in water. Therefore, water with high alkalinity can maintain a more stable pH when acids are added. Finally, this experiment helps us to understand the water chemistry, monitor water quality, and improve the treatment process. It is also for a safe and high quality water.
Now, I will explain the importance of analysis of water quality using pH measurement and acid-base titration. Volumetric analysis is very important in water quality testing because it helps ensure that water is safe for different purposes such as drinking, agriculture, and industrial use. This method can detect contaminants and monitor changes in water quality over time, allowing the appropriate treatment to be carried out when needed. In addition, volumetric analysis is simple, cost-effective, and provides accurate results, making it one of the most widely used techniques in water testing laboratories. In conclusion, volumetric analysis is an essential method for evaluating water quality. It provides precise and reliable data on important water parameters, helping us determine whether water is safe for use. Regular water quality testing not only protects human health but also preserves the environment and ensures sustainable water resources for future generations.